All right, today we're starting part 3 of the Peterbilt frame stretch. If you are following along, part 2, at the end of it, I told you that we have the liners ready to go, but we're going to have something special for welding them back together. I was contacted by, occasionally from time to time, I will put pictures of the projects and the progress that we're making on Instagram or our Facebook group, JC Smith Projects. And in this case, on Instagram, one of the representatives from usaweld.com, they are a company that provides welding equipment and supplies, and they also specifically supply HTP welders, plasma cutters, and so on. So they reached out to me and asked me if I'd be interested in checking out one of their new welders that just came out. And I said, well, possibly. And we got to talking, and they said that they would be interested in sending us the welder and also sending out one of their representatives. Now, the representative they were going to send out to us was Peter Zila. Peter Zila has been welding for 25 plus years. He does all the same kind of work: frame stretches, industrial repair, truck repair, equipment repair, welding, fabricating, only, on a much better scale, much higher scale than we do. And they asked if we'd be interested, and I said, well, certainly, because I've actually never had anyone teach me how to weld. I've just kind of fumbled through it, as I always say. So I thought it was a good opportunity to not only check out a good welder, but also get some welding lessons. Now, Peter has done a lot of frame stretches and this type of work, and he had a couple procedures that he thought might be beneficial to us because of our frame stretch. Typically, every time I've done this, I've used typical, normal 35 thousandths MIG wire, much like this right here. This is 35 thousandths, yeah, MIG wire, and I would just weld my joint together, back it up with a liner and all that, and be on our merry way. And Peter introduced us to, like I said, 2 new procedures, one of which was very frame flex savvy, or beneficial to how a truck frame can flex. And that is a procedure called Flux core with gas shielding. So we're going to show you that in part of it, and also we're going to do a pulse spray transfer weld as well. I don't want to sound like I know what I'm talking about. I'm just repeating what I've learned from Peter in the last couple days. But anyways, this is the equipment. This is it's called the ProPulse 220 MTS. This is a very capable machine. Apparently this machine will do everything that we have been doing in a much smaller case, for sure. It's a very versatile machine. It'll do stick, TIG, MIG. I think there was one other thing. Oh, stitch, yeah. But in aluminum. I believe this one does aluminum too, yeah. It's really easy to set up. It's, well, I'll leave you a link to where you can go through multiple videos they have based on this right here. There's multiple videos on how to run it, and it's very detailed, and you really need to watch all them videos so that you can get a good idea how to run the machine properly, because there's a lot going on and a lot of adjustments. And after Peter left, I lost the settings, so I had to call him back and get it. So anyways, they sent me out this with Peter, and they sent me out with a nice gun, the ground lead, the working clamp. This is a extremely strong clamp, which that's a nice upgrade from some of the others we've had. He brought us the 2 typical 35 thousandths wire, MIG wire, and then he brought us this Flux core 30 thousandths. The welder came with the Victor flow meter, a hose for your cart, and then this is a spacer for the wire if you're using a small one, the smaller version. And then Peter asked me, he says, do you have a plasma cutter? I said, I do. It's a HP 45, and I'm having mixed results with it. Sometimes it's good, sometimes it's not. So he says, well, I'll just bring you one of them too. So we got to use that. We used this, and we cut a CV shaft. We cut a CV shaft, which is about, I don't know, that's probably 1.25 inch diameter, in a single pass with that machine. That was pretty impressive. So anyways, we didn't get a chance to properly introduce Peter, but you'll see him in the video to follow, and he's showing us the techniques, and man, it was great meeting him and learning all the different stuff, because what a difference. When you have an idea of why you're doing something or how to do something, and when you're having troubles, what to change to get there. It's made a big, huge difference, so stick around and we'll get into the actual welding. I don't talk to the camera a lot during it because I was trying to focus on what Peter was teaching me. If we have time by the end of the video, we will be working on the frame splice. If not, it'll be next time. But I'm talking to you in the past tense because Peter's already gone and I've already done all the welding, so hope you enjoy.
Up, either straight in or a little bit pointed up, going up. The next one, you go left to right, kind of over the middle, and what you do is you hold it like 1001, 1002, kind of like, not really flick over the middle, but almost hold it 1001, 1002, and so on and so forth.
So you're saying quick over the middle, but
yeah, because otherwise the middle droops.
Right.
And what happens on the outside, the first second it's kind of carving, the second it's filling.
Okay.
So you really got to take your sweet time. Like in my mind, okay, you may not see this on the gun. In my mind, I do kind of almost like a shallow U or C shape. I kind of go quick over the middle, and then the 1001, 1002, in my mind, I go like a smidge up and down, and then I go over a smidge up and down, and I make sure that every pass I do, I'm going to shoot for a 3/4 overlap the previous, and then I feel rushed, and I end up half overlapping. But if you shoot for half overlap, you're going to do what I call the Christmas tree thing, where you have a bunch of voids, you go up like a triangle. So you see how it has a little bit of a belly. On the first one, that's kind of normal.
Kind of sticking
so now,
out.
Yeah, so now when you do the next one, it'll smooth that all out.
Okay.
So when you look at that one, that's pretty much flush already.
Yep.
There's a tiny bit of a belly, maybe here, not really there. And then the overall outside there, depending on which textbook you read, you don't want to go further than 5/8. It depends on which textbook you read and what you weld.
So as I'm watching you, I see what you're saying. It was like you were like 1.5 and then roll over 1.5.
Yeah, and you saw in the
another.
beginning it was kind of, I'm just going to point with a cold gun. I'm going to take the finger off the trigger here. You see this right here? It almost looks like there could be some undercut starting. I'm not waiting long enough there. Here is perfect. Perfect toe, no undercut.
Yeah, because you've melted in, but you hadn't filled here.
Yes.
Yeah.
That's when you get rushed too quick.
Yeah.
And then you also put too much heat in the middle, and then the middle droops.
So what
You want to put the heat in the ends, not in the middle.
Gotcha. And what he's talking about is here it's undercut. You can see some of the metal is kind of missing.
Yeah,
here,
there's like a
but
little
here,
line, like a little trench.
Right here, it's all melted together, where it's like smoother edge. Where here, it's kind of cut down. I see what you're saying. So that would have been a little bit longer pause here to fill that in.
The next one will make up for it too.
Yeah.
And now you finish the rest all the way up. So overall, I would have gone a little bit quicker over the middle.
Okay.
Of course, now see the heat rises, see how orange the backside of the part is.
Mm-hmm.
That's kind of working against you.
Right.
A little bit quicker over the middle, and if you do a little bit longer stick out, because the machine compensates for it, it's not like it's losing settings like some other machines do. You can weld from like an inch away and the machine will just compensate. It won't be sputtery. Mm-hmm. Then it gives you more room to see like
what's going on
around the cup. Yeah.
Okay. always had has been it's sagging, you know, like it was too hot, too much of it, and I couldn't get up. And like here, I see inconsistent speed across here too. Like
yeah, but the next,
holding,
if you let this cool, like for another 5 minutes, if this was like a hitch plate, 1/2 inch, 5/8 thick, and that was a 3/8 frame, it would take the heat better too than
right.
this.
Plus we're getting close to the end of it.
Yes, so now if you let this sit and cool a little bit, the next pass that you put over this could look just like that. Because it's not really out too much where you don't even have to grind it back in. You just have to stay in the corners a little bit longer, and the next one will smooth it all out.
Over the center a little bit faster.
Yep.
Yeah, so just hold a little longer on the outside and then make my move over to this side faster.
Yep.
Yeah. Throw a hump in the middle.
There's no hump. That's all fixable. The next pass will make it all flat.
So you think that setting is good?
Same thing. Left, right, stay 2 seconds. 2 seconds on every end and kind of whip over the middle.
And a little bit longer, stick it out. Hot.
Yeah, well, look how nice this looks.
Not so bad, huh?
No, for a guy who says you can't weld vertical up.
Well, I do have a common saying in all my videos where I weld. I'm not a welder.
Yeah.
Well, now you are. Go back to the pulse program. Select 83 amps, whatever. We had 84 before, 87. So that should be about right. And I think I got this feeling that gas tank is a little cold. I'm going to start out here. We're going to see how good or bad it's going to be for us. Yeah. And then your stick out. Remember, this time you need to be further apart, further out, because it's spray art. The spray art needs room to breathe. So that's basically.
So what was the pop you were?
There was a couple of droplets that were a little bit bigger, and you can kind of see them flying off. Maybe you need a little bit more voltage, or just when you weld on really low settings, the spray arc doesn't like it that much yet. When you go to like a higher setting, let's say here, 1/4 inch material. So, you know what it was? Dirty material was the popping. The contamination when it was pulling it out of
The dirty material was pulling your heat.
yeah, so the dirty material, the spray arc doesn't like to go down. It needs some power to go through, and then the droplet didn't detach right, the one, and then the next one was double size.
Oh, I see. So it built up.
Yes. See how nice this is?
Yeah.
Now let's try this on here. Let's mess up your frame. And you see how deep it washes too. Wow. And I wouldn't even grind that.
Yeah, I wouldn't either if it looked like that.
This is so hot, it's gonna go through your gloves. Your hands are just gonna burn. You gotta try to weld from here, hide behind that flange. So
Yeah.
here, let's do that one. Well, you know what? Why don't you do that one?
Does that stick out far enough, you think?
Yeah, that's good.
Further away?
Yeah, you moved right in. I would have gone further and just overlapped this 1/4 inch. You stopped just 1/8 inch shy of.
Should we do a little more?
Yeah. You're too close. You can hear that by the pitch.
Yeah. So farther away.
Yeah, that's spray arc. Spray arc needs room to.
We got oil in this.
It'll burn off.
Okay.
You have enough cord?
Yeah.
I know 20 years of muscle memory. Try to weld from further away with this spray arc. I know it's muscle memory taking over. You're not doing this on purpose. You're getting there. This is like
So was this a little slow or too far away?
too far.
right
when
there.
the pitch
So-
dropped too much, it was a little bit too far away.
Okay. So if we go a little closer, then it'll fan out a little. Or if I go a little farther away, it'll fan out like this
Yes.
is saying. Okay.
I kind of helped screwing you up here. This is the one we should have welded because
Yeah.
that was clamped.
That's okay.
I don't think it's pulling all that much.
This
It
one
doesn't look like it is.
This one has weld on the back
Oh, okay.
a little bit. That one does not. Stop.
Yeah, it detuned itself. So watch the display. See, it says attention over current.
Okay.
When the pitch really dropped a lot, then it dropped from 629 to 500, and from like 180 amps or 200 amps to 547. So what you do is you dial it back up,
Okay.
pull the trigger once, clear the code. Now you can weld.
Okay. So why did it overcurrent? Was it?
So it does that too. When you move in the gun too close,
Yeah.
the closer you are, the higher the amperage is. The further you away, the higher the voltage is.
Okay.
When you go over 200 amps, see, you're only supposed to have 175. So if you go over 200, that's because the old short circuit make habit makes you go in, and now it goes over 200, and to not blow up the internals, it lowers the output. So you can still finish the weld if you had to.
Is that why I was hearing it seem like it slowed down?
Yes.
Okay.
Because this is direct. The frequency is directly related to the wire speed. Remember how I drew the shape of the pulse?
Mm-hmm.
The droplet that is cut off should always have the same size, no matter if you weld thin material or thick material. And in order to keep the droplet the same as your wire feed increases, the pulse frequency needs to increase to chop the same size droplet off.
Okay.
Higher wire feed rates, higher pitch. Lower
Okay.
wire feed rates,
So
lower
that
pitch.
higher pitch would be what we're.
Yes, that's
Yeah.
more power, higher
Okay.
pitch.
So when we hear that lower tone, then we know we need to.
Yes. Yeah, right there. Always overlap them 3/8, maybe even 1/2 inch.
Yeah.
And then, let me show you a trick.
Okay.
I'm programming trigger jobs. See, the first 3 are blue. You can adjust. You can pull those. You can by trigger pull adjust. You can by trigger pull adjust what you're doing there. Override, yes. So now what I'm gonna do is I'm gonna get out of the job mode. See that little star needs to go away?
Yeah.
Makes a triple beep. And then it says job line. Now I'm gonna pick a short circuit program like we just had. Select with, 250 inches a minute ish. Job, save as number 2. So now, when you click the trigger right now in the air, click quick. Job 1, quick, job 2.
Oh.
So now what you can do is, with this 248, you can go now and fill this hole, for example, right? And then you can go and fill this hole. And then if you wanted to do something hot again, like here, click job number 1.
Now you're back to the first
Now
one.
I'm back to the first one. Wait.
Now you can click
Wait.
again. Go
Yeah,
back.
now I'm gonna go over it again. There.
Nice. All by clicking the trigger.
Yes.
Just go between the two, so you went
Yes.
back to the short circuit MIG.
Yeah, to fill the hole and then run the hot pass over it.
Because the short circuit MIG allowed you to fill that
To
hole
fill the
without
hole
melting
without
away.
falling through, yes.
Nice.
And if you pull the trigger for more than 0.3 seconds, it's not switching between gears. You have to click less than 0.3 seconds.
Okay.
Or if you strike an arc, it's not switching gears either.
It's only if you don't.
Only if you have no ground and if you're less than 0.3 seconds.
Okay. We're gonna back over this one.
You don't weld into your, that you may.
Switch?
No, not yet. You were still the post flow. There's 2 seconds post flow.
Okay.
Now it's switched. There you go.
And then hit it again.
Yeah,
I heard it.
yeah.
Oh.
Did that work any better than
Oh.
the previous machine?
Well, that and instruction, you know. Look at all of what we've learned just in this little bit of time, you know.
And if you think this is awesome, then you got to put the dual shield wire in. That'll be really.
This is just different gas.
This is different gas and a different process. This is a hotter gas. You can't with 75-25. You don't get a clean spray arc. It's not enough energy in it.
And
I
that's 90-10
mean, 90-10
and 90%
argon, 10%
10%
CO2, instead of like 75% argon and 25% CO2.
which is what we normally have. it'd be hard to not be happy with that. I mean, there's some imperfections, of course, but all in all,
It's a, what, 30-year-old truck. There's gonna be imperfections on it.
I think that looks good. It seems faster than the.
oh my, it is.
Yeah.
Certainly is.
See, you're doing so good. This looks like a professional welder dude did it.
It's better.
Nice and uniform, no spatter.
Getting better.
You can start your arc outside and tail in. That way you're bringing some heat into the part as you tail in, because you're gonna kiss it off with a grinder later on anyways to lay flat.
So what you're saying is you're getting your start with this
Outside, outside, and then I go in.
So
Yes.
you're basically heating the metal before
Yes.
you start
Yes.
actually
Just a
welding.
little bit, like
Yeah.
3/8, whatever, you know.
Yeah.
Like I intentionally not start in the joint now. Am I missing the joint? No, I'm hitting it. I couldn't see. But now watch this.
Yeah.
There. No real chipping required,
Yeah.
and almost flush. So now here I gotta start in that. And see, I don't go to the leading edge so it doesn't fall down.
Yeah, if you step held back
Yeah.
a little bit, let the
And let
puddle
it
work
fill.
out.
Yes. Now, if I really wanted or felt I needed to drag, I'm gonna mess up our pattern here a little bit. You're gonna grind it anyways. This is a non-visible side. I'm gonna show you what dragging would be looking like. In my opinion, it gives shallower penetration. It also, in this case, with a narrow beat, that's probably all you really need here. It's vertical up, keep it at 400 inches a minute, roughly.
400 to 500.
Yeah, 400, 450 maybe. 500, you better have thick material and you move quick. And then flat on this, just wrong, like open.
And it's the same stick out as the spray.
Yeah, kind of. Similar. This, you can see, will grind a lot easier than that, because this has a slag shielding. It cools slower, it doesn't air harden.
So it's not as hard.
Yes, it's not as hard. Yeah.
You were right. Remember, you said it gets hot.
It gets hot. This
That
shit
gets so hot so fast.
This is like the real deal,
Like-
you know?
Like my finger's on fire, and that's what happened towards the end of that.
Yeah.
Yeah. I have to. I'm quitting early because I got.
I hear you.
Look, that's ready to pop off.
Yeah, that'll pop off right there.
Look at that. Look at that. So interesting. Yeah, I'll have to get something better for my fingers, man. That's hot. So now I need to go.
Now you need to go from about
This way again.
6 inches out, that way, back drag it again.
Okay.
And then to fill this really, here you were slow enough, there you almost need to do a little bit because it's just so wide, you know?
fanning out farther with a little wiggle and a little slower.
Yeah. And it lays flatter too.
Mm-hmm.
Less grinding later on.
Yeah, we like less grinding.
Yeah, I like that too.
Good grief, man. My hand's on fire.
Oh, I can weld the whole thing. I can
With
weld this
them
whole
gloves?
thing. With these driving gloves, not even welding gloves, I can weld the whole thing. Yes.
Not this guy. Lord, that was hot.
Jeez, yeah.
No, it's not. It's not. I said shit because it was falling through because I couldn't fit it like that.
Look at that. And that'll grind so much easier, huh?
It will. I mean,
There's something gratifying about knocking that slag off.
yeah. 54 psi. This
Oh.
70, the 70 is your target, right?
Yeah.
You need to be flowing to see actual air pressure. Because if you are not flowing, it's not showing you actual air pressure. It's showing you target air pressure.
We may not be up there yet.
Yeah, I was gonna say your air compressor may not.
Well, then we better just wait before I start making major adjustments.
Man, look at that. Look how clean that is.
Yeah, but for 1 inch, you have to be patient.
Yeah, that's incredible. I cannot believe. Look how clean that is. See it?
Yeah, nice.
All right, so this is the first process that Peter showed me. This is 35 thousandths solid core wire with 75-25 argon CO2 mix as a shielding gas, and this is set at pulse. So this is a pulse MIG. This is the first, we had this set vertical, so this is the first vertical uphill weld that I was able to do that didn't sag and drip and look horrible. Having someone here to instruct you as you make them little mistakes is just invaluable. So as you can see here, it's a little bit humped up in the center and then it kind of levels out. So what we did is he instructed me to do one single bead up the center to get it a base, and then come in here, and this was pulse MIG set at about 450 inches per minute. He says if you're going vertical, we want somewhere between 400-450 inches per minute. So we start here, and he instructed to come over to one side, hang out for 1.5-2 seconds, and then quickly come over your weld, hit the other side for 1.5-2 seconds, then back to the other side, and then just continue all the way up. But you can see what I ended up with was there was a few times I kind of favored this side and didn't get quite enough on this side over here on this plate. But as we got to the end, I was getting a little more uniform. But that's the first successful uphill weld I've been able to do, uphill vertical. And again, that was 35 thousandths wire on 75-25 mix of argon CO2. The setting, I can't remember the voltage, but I know the inches per minute were right at 400 to 450, but I think we're set at 450. So then we move to this. This is pulse MIG using 90% argon, 10% CO2, and this was turned up to the max, which is right at 600, right about 600 inches per minute. And this had a much bigger stick out and distance. So you hold the gun a little bit farther away so that the stick out is much farther, and you get a better spray pattern, because this is spray transfer, he says. So this is a very, very hot weld, and it's more fluid-like. Peter did this one down through here, and then I tried my hand here. So under his direction, what we did is, where these were just welds we used just to hold it together while we were doing it, I had that ready to go before he got here. And we come into the weld overlapping about 3/8 to a 1/2 inch of what we already had, and then we moved in. And as you can see here, I had a problem because I'm used to doing just regular short circuit MIG, where I'm too close to the material and the puddle. I needed to keep pulling back off, and you could see where I got too close again, because it starts to get humped up in the middle, because the puddle, the fan narrows up as you're welding. And man, I don't want to sound like I know what I'm talking about, but this is just what I've learned yesterday. But as the closer you got, the narrower your fan got. So I had to keep moving out, and you can see it's relevant. It's evident here. As you can see, it starts to lay flatter, and then I catch myself, or Peter catches me getting too close again, and then I have to fan out, and again, you know, it's just that habit. You're used to being close, and then as I keep going, it starts to get a little flatter and a little flatter and a little better, and so on and so forth, all the way down. Now, this isn't ideal metal because it's rusty. Even though we ground it down really good, you know, you still get imperfections in there. And then you get to points like this where there's holes like this, but they're in the middle of our weld. So that machine has a really neat feature where you can set the parameters to do this, like this, and then also do regular short circuit MIG or a different operation using the same gas. And what you can do is you can toggle between the two different settings right on the controller itself, just by waiting until the post flow of the gas is stopped. You know, that gas that rolls over your weld just for a few seconds after you've let off the trigger, just to keep the impurities out, I suppose. So after that post flow stops, you hit that trigger for less than 3/10 of a second, and it will trigger to the next job you have saved. You can save, I think, up to 5 in there, if I remember. Now the thing is, you can't just trigger between two. So if you have 5 saved, you have to go click through. If you're on the top one and now you need the second, or you need the next one, you have to trigger all the way back through to get to them. You can't, and then, you know, you have to be conscientious of where you're going. We were set up on 2, so we could just go back and forth, and that's what we did here. We went from that pulse MIG set up at 600 inches per minute down to something much smaller on just a short circuit to fill these holes. And that was very nice, because of the speed, the fact that you didn't have to go back to the machine, change settings, then go back and when you're done, change them again. That was pretty nice. And then the third operation he showed me was this. This was flux core, 30 thousandths flux core wire with 90-10 argon CO2 mix, shielding gas over top of it, and a pulse MIG setup. So we had the flux core wire, and then we had the shielding gas on top of it of 90-10, and then also in pulse MIG. Now the purpose of this procedure here was because the tensile strength of this wire in this procedure tends to be more flexible than your standard short circuit MIG. Again, I don't want to sound like I know what I'm talking about, because I really don't, but that's how it's explained. And this will allow things to move rather than crack, or it will have more movement than other procedures and less likely to crack, I think is the best way to say that. So what we did here was I started here and pushed it this way, and you can see how hot and even the lines are here where it got into the frame. and I would start this way and go here. And right in here, what you're seeing, these wide ones, is where my fitment was a little bit gappier than the rest of it, so I had to kind of weave back and forth. But even so, it's still, we have no holes in it anywhere. You know, it's a very, very hot puddle. I mean, it's so hot that when I did this and this is about as much as I could do at one time, because the heat was so great. It was burning through my gloves and burning my hands. That's how hot it was. You can see here, it would just burn away at that metal right there. Of course, that was an edge. But so what we were doing is doing a little bit and letting it cool. So by starting here, coming this way, it allowed this part to cool. So when you hit the next one, you're going this way, and now it's starting to cool. And you're working on a cooler spot. You're working towards a cooler spot. Well, then Peter started going. He said, yeah, you can run that all the way down through. And I said, I just can't do it. I'll burn my hands. And we kind of got ahead of ourselves. And what ended up happening was we were doing good with that procedure because it kept it good and flat. You know, we have no dips whatsoever. But this is how much heat goes into this weld that he did from here to here, I think it was right here. This is where he stopped. And in this right here, you'll notice that it started to pull the frame. So there's an 1/8 inch right there. Down here, we're probably still an 1/8. At this end, probably a little bit, right about an 1/8 with ground down. So we got ahead of ourselves, and by doing that big long weld, it kind of pulled that liner. And I'm cleaning it up right now, but we're gonna have to pull that back out. So, and I had braces, but we just started going and kind of, you know, was more interested in the procedure than, you know, the actual material itself. I probably should have been working on something not so critical, but I tried to put a C-clamp on it to see if I could pull this together, see what it would do. But I think we'll be okay. I can get that fixed. I just want to grind this flat now because I want this to lay up against my frame 100% flat. I don't want any humps like this up against the two frames. So that's what I'm working on now, but that's the procedures. It was a very, very interesting day, and I learned so much. I'm still not a welder, but you know, at least I have some better techniques that were actually taught instead of just figured out or tried to figure out. Well, the welding is all finished on these, and I've got 2 coats of primer on both sides. Now I'm waiting on the primer to dry. This is taking forever. It's pretty cold out. So we're going to let it sit overnight, come back tomorrow. I'll get 2 coats of paint on it, hopefully. And we're going to have to start on how I'm going to splice this and how I'm going to support the frame. I don't have what I need, so I can either make it or I can buy it. So I got to figure that out.